Hello friends, सबको नमस्ते. So today in this video we will create a blood cell image segmentation model using a FCN-ResNet50 model. Before that, we can see the dataset. Train images look like this, blood cells images. Okay, and these are the mask, or you can say the labels, annotations, anything you can say. But these are the mask of the images which we use for the segmentations. Okay, and these are the test images with images and the mask. So let me open this Jupyter file in the Google Colab to explain you, and this is the helping code. I will explain you later, and this is a weight file which is trained on 50 epochs. So let me open this in the Google Colab. Okay, so friends, this is a code. Let me run this, and this is a library which we use for connection of a dataset with the Google Drive, or you can say connection of Google Colab with the Google Drive. Okay, let me show you how you can connect it. Suppose you uploaded your dataset in a Google Drive. So copy this link and make sure that this is on tick on the anyone with the link. Okay, just copy the share link and paste it here. Okay, and keep this part only till this to this. You can say that this is a unique ID of your data set. Okay, use this and paste it here. This is a zip file name, and you have to unzip it. Let me show you. This is a zip file. When you unzip it, you will get this type of you can say data set of test and train. Okay, and train contain, I already shown you that train contain two folders, images and mask. Okay, so close it now. These are the libraries which we use for creating the models and train the model. One more thing, instead of using a data augmentation or data augmentation, a transform, because in Torch in PyTorch we use torch vision dot transform dot transform dot compose, that thing for data augmentation. But in this case, for image segmentation, we can use uh, Albumentations as a and Albumentations PyTorch import to tensor for converting the image into a tensor format. Okay, so don't worry, you can use torch vision dot transform also, but for this time I'm using this augmentation. Okay, for data augmentation part. So let me run it. Now these are the directories, image directory and the mask directory. We will now get all the file name presented in the image directory. After that, fig basically representing the entire image, where the subplots has to be plotted. Axis here is in a 2D format, and when we use Ravel here, it converted into a 1D format for the easy to iteration over the subplots. And here plot dot subplot, where 4 is a column rows and 8 is a column. Okay, so it should be like we are representing 432 images at one time. Okay, and each size is 24 into 4. Now here alpha, you can say what is use of alpha is for the transparency of the images after the segmenting the images. Okay, now I will explain you this whole part with the help Jupyter code which I have to shown you, like this one. And this is the help code. I will explain you this. I will explain you. Okay, so this is a class. We have only one class, blood cell, and for the 0 it is a background, and we do not need that. That's why we are just creating the dictionary which presenting one has a class name. Means representing the color which is used for segmenting the class names. Okay, class name is the portion is there. Let me show you this. Say if blood cell is there, this portion is representing by the yellow color. Okay, so this thing is there. Now we are iterating over it. We are iterating 16 times. because at each one time we are representing two images at the same time, means original image and a segmented image. It means at one iteration we are representing uh, 16 images. 32 divided by 2 we'll get 16. Now random images, choose any random images from that, from the image directory. Now we have to create the image path for opening that image. Now for the mask, you can make sure when we use the data set of image segmentation, it is possible that images is in a JPG format. You can see in a PNG format right now, and mask is also in a PNG format. But sometimes uh, there is a data set in which the train images and a mask extension is different. So make sure that extension is extension should be same, or you can say that during plotation time you can change the extension, just replacing the last four characters. Okay, now we have get the mask path. Okay, and you know that image mask and the image name should be same. Now we have to read that image, and we have to after reading that we have to convert that into RGB format, because you already know that CB will read the image in a BGR format. Now here mask is why we have to use here, means we have to read the image in a grayscale format. That's why we have to use here 0, which read the image in a grayscale format. Now when we there is a chances that there is a pixels value which is greater than you can say 0. Okay, so we have to convert that all this pixel value which is greater than 0 to 1. Okay, you can say that convert any non-zero value to 1, means every value which is greater than 0 is changes to 1. So this whole part and this part, all thing, let me explain you with the help of code. This is a help code which I had made for the explanation. Suppose this is an image of 3 by 3. Okay, so to fetch the channels, R channel, red channel, green channel, blue channel from the image, we have to use this thing. Image 3 dot and 0 will give me the red channel pixels value. This one will give me the green pixel value, and 2 will be give me the blue pixels value. Let me print this. See this. One important thing which has to be noticed, that 25 this the 25 1 2 will be represented here. 25 3 25 represented here. 128 64 9 192 represented here. For the red, for the first red, you can say red region in an image, or you can say the red channel. Now for the green channel, we have to use this 0 25 0 0 25 0 25 25 0 25 25 0 and 128 64 192 128 64 192. Same for the green part. Now why when we retrieving that 0 1, and how we have to read the images for retrieving the red and green channel. Let me show you one thing. You can read this document for your reference, to read that, to know that which region is present in the red and green and blue. See this is the entire image. This is the entire image, and the red part is this one, this line, this line, this line, this line. Blue line is this one, since not blue, green is line, this one, blue one is this one. This way we have to read the images when the image in a numpy array format, to retrieve the red channel, green channel, and blue channel. Okay, come back to our solution. Suppose see what I am doing here: blending image, overlay, NP0 like 0, mask, CV root. What is this whole thing is happening here? Let me explain you in this way, in this example, through this example. Suppose this is a mask. This is a mask of the image which we are using. It is in a grayscale format. You had already seen. So See the use of this thing, this line, convert any non-zero value to 1. Why I'm using this? When I am reading the images, there is a highly chances that that white portion is represented by the 255, 255, 255. But I want to convert that into a 1 because class name 1 is representing the pixels value. Okay, so I have to convert that. That's why I am just using that mask greater than 0 convert, and it will convert that mask into a 0 to 255 value will change into a 1. Now this is the overlay, you can see this overlay, convert overlay the image shape to the image. Okay, this way give me the uh, you can say the numpy array of 3 by 3 into 3 of the image format, image width and height format. It will give me the numpy array of zeroth value. Every value will be 0 here. Now see this, what is happening here. And this is an image. Let assume that is the image. Now what is the use of alpha class names, before mask, after mask? Let me print this. See this, before mask the masks look like this, 0, 25, 25 value, but I want to convert all the values which is greater than 0 to 1. So after using that line, it's converted that into a this form, 0, 1, 1, 1, 0, 1. Okay, now we have to iterate over a class color item. First thing, it will retrieve me class id means 1, and color will give me this thing, this 25, 25, 0. It will give me the color value. Now after using this, we will have to create the class mask. But which this what is the use of class mask here? What is it's give me the detail that which portion of the image is representing the object which for the segmentation. Okay, in this type, see mask class id, miss here, see mask. Here mask is 0, 1, 1 value, means at 1, 1, where the 1, 1 value is there, it means the the object is there for the segmentation. Okay, this is the portion for the segmentation, representing this. We have to change only that portion only on which the object is present for the segmentation. That's why we want a class mask. When we print the class mask, it give me this detail. Let me run it again. See here class mark, what is here, see overlay is 0, 0, 0. Class marks is give me the boolean array false true true false true true. Here true true representing this part 1, 1, 1, 1, means it is saying that if this particular thing, this particular array 2D array is saying that at where is the true value is present, at that portion only the segmentation has to be performed. Does not change the portions where the false is there, because they are tight portion. Segmentation does not need to be performed. Okay, so that's why we have to use this line, class mask class id. It gives us me the boolean to the array which give me the detail that at which portion we have to change the pixels value for the segmentation. Now for C range 3, it's basically iterating each channel of the overlay. Okay, now what is use of class marks? Till here it will retrieve the overlay channels value of red, green and blue. Now class marks, what is use of class marks means at the portion of the class marks mean where the true value is there, only at that area only you have to change the value. And what value you have to change? Class C, means here C is first iteration 0 value, means at what class C 0, C not class is color 0, at color 0 value will be 225. At green portion, at green you can say at green channel, when we have iterate over the green channel, value will be 225. At blue channel, right value will be 0, 0. See how the value is changing. This is an overlay. See overlay red channel. See this, true true 25, 25, 25, true, where the only the portion where the true is there, it's change only that value. That's why use of class marks is here in this line. Okay, now this is a green channel. Now we will talk about the, sorry, this is a red channel. Now this is a green channel. Now it green a second iteration, color index color 0, color 1 value will be 25. So that's why it changed the 25 value at a portion where true is there. But blue layer, for the blue layer, see that at third channel, when we moving to a blue channel, its value is 0 here. So you can see that when we moving to a blue channel, nothing has changed, because at true portion, we only have to change the value of the color only at the green portion. At the green portion of the color variable, it's a zero value is present, so there is no need to change. Okay, now after overlay means after retrieving the channels, this is a first red channel, this is a green channel, and this is a blue channel. Now 0 25 25 reaches here, 0 25 25, 0 0 25, 0 0 25, 25 0 0, 25 0 0, 0 25 25, 0 25 25, and 0 0 25 25 0 0. This way channel converted to the overlay. Now we have to create the blended image. So this is a formula to convert the image into a blended image, where the image, after we use this, we get the image with the segmentation part. Okay, so let me explain you this thing by using this way. Suppose this is a final overlay of each of channels. After getting this, we have to convert this into a, this is just a channels. This is not an entire image, entire overlay. Okay, so we have to convert this. See this, I already tell you how it's converted: 0 25 25, 0 25 25, and 0 0 25, 0 0 25, 25 0 0 0, 25 0 0. This way the entire overlay image formed. Now this is the channels of the image, and this is the channels of the final overlay. Okay, now see, I already explained you how to retrieve the channel from the image. After getting this, say this formula. Let me explain you this formula. Okay, this is a channel. Let's see, will be 0 here, means we are moving to a red channel only. So first retrieve the red channel portion of the overlay and the image, and see this is the image 2500. So I have retrieved it. This is a channel of the overlay, red channel of the overlay. I have retrieved it. Now see this, mask 001 means mask 001 means only change that pixel value where the mask is 001, where the pixel value is 1. Here 1 is presented here, so we have to change this pixel value. 1 is here, change this pixel value. 1 is here, change this. 1 is here, change this. We did not replace, change, or modify any pixel value other than the pixel value where the 1 is not there. Okay, now after changing, see here, what is use of alpha? What is use of alpha? Alpha means 0.5 means 50% transparency. Okay, so when we 1 minus alpha, 0.5 minus 1 will be again 0.5, means when we multiply 255 into 0.5, you will get sorry, this 255 will not be changed, because 1 is here, 1 is here. Okay, mass 001 is meaning that we only change that value where is mass is 001. So way 0 0 nothing has to be changed, 0 0 nothing has to be changed, 1 we have to change this value. 255 multiplied by 0.5 you will get 127.5. Now here is 1, 128 multiplied by 0.5 you will get 64. This way you get the value. We till here this entire calculation is till here. Okay, now this is a second calculation. This overlay at channel 0 channel will be this thing. Now multiply 0.5 only at that position where the mass is 0 0 1. So 255 divided by 0.5, 127.5, 127.5, 127.5, 127.5. This way you retrieve this. Now plus is there. Just add the 25 plus 0, 25. 0 plus 127.5, 127.5, 127.5. This way you add and you will get, this is a, you can say, red channels value. This is a red channel value, but this is not a this is not a, you can say, uh, these are some values in a float values. But when we final channel will be after replacing point 0.5, after converting this float values into an empty value, you will get red channel, green channel, blue channel. Okay, this way you calculation has performed. Now suppose when you get this red channel, green channel, or green and blue channel of the blended image, you will have to convert that into a blended image. How you have to convert that? 25, 120, 120, 225, 255, 127 and 127, 255, 127, 127, 25 0 25, 25 0 25, 191 64 192, 191 64 192. This way our complete blended images used. Okay, is come. I have explained you everything here, what how the performance is there. Now see this, you can use this instead of this thing. Instead of this thing you can use this, but I'm not using it. I'm manually converting the pixels value. Why? Let me show you. See this, if suppose I will not I will use that particular function cp2 add weight function. This function I will use, so it will change 255 value also, 255 value also, this 255 value also, this to 0 value also. Means it will change entire values present in this present in the channel. But but I want only change the value where the mass is 0 0 1. Otherwise does not change the value. I don't want that. So let me show you the effect of manually change and using of the function. Let me first run it. You can see that when I use this function, this is a function which have a same formula, blended 0 image 5, but it change entire image and make the image dull. Say this is original image, but it's a segmented image with a dull format. Dullness is there. But suppose if I manually convert the pixels value, because I want to change only those pixel value where the mask is 0 0 1. Let me show you the difference. See, after manual conversion, it's only segment those portion where where the object is present. Only change that pixels value, and also see the dullness is not there. This is a use of manually conversion and using of the function. Okay, so let me close it. So this is a code. This may let me explain you one thing line by line again. So this is a image. Open image mask path, over the image converted into RGB format. Then first read the marks in a grayscale format and convert all the pixels value where the pixel value is greater than 0, make the overlay of 0 with of height and width of image. Now iterate over the class colors. It will retrieve class class 1 means marks where is marks is equal to 1, convert that into a overlay. Okay, this way it's converted. We will fetch this. Now make a blended image as an image copy. Now convert the pixels only where is a mask is 1. We only want that. This way we will get our blended image. Just plot them. Okay, this way our plotation has there. Now we are using FCN-ResNet50 model for the segmentation. FCN is basically fully convolutional network. See this, fully convolutional network with ResNet50. This is, you can see the architecture of it. Okay. So this is a device torch.coder is available, means which device we are using during training. We have to use that variable. Okay, because we want that model, the images and everything has to be on the same device. We have two things, background and a blood cell. Be two classes we have. Okay. Now this is a repetition. Now load the model, pre-trained true model FCN, and just model the classifier for tossed and dot convert to 522 length classifier convert. Let me print the model for the better explanation. See and see this. This is a classifier. We have to change this. An auxiliary classifier FCN. There is no need of auxiliary classifier in our training time. So we have to use auxiliary classifier is equal to none. Okay. So we have to change this 512. It's a pre-trained 20 here's 21 meaning here is pre-trained on a 21 classes and 0 index value is a background. So we have to change this according to our number classes which we have. So how we have done it? Say this. Model the classifier for, say, move to model, move to classifier, move to fourth layer, conventional to change the in channel to 21 to not out in channel, out channel from 21 to 2, because we have two classes, one is background and one is a blood cell. Say that language classifier kernel size will be 120, and we do not need any auxiliary classifier because there is no need of that. Just make it in the same device, learn it. Now this is the blood segment class. You can say class which is useful for the data loader to load the dataset for during a training time. So let me explain you one thing easily. This you can say this is a, you can say class superclass which we use for the which contains some functionality which we can use in future. Okay. Now this is a directory, image directory, passing the image directory, master directory transformation is if any transformation is there, in if any data augmentation has to perform in an image. Okay, you have to initialize them, image file name, shorted, or list image directory, shorted. Okay, this way we retrieve. What is the use of the shorted or list directory? Because it retrieve all the file name present in that particular directory. Now we have to also give the class labels, 0 for the background and 1 for the blood cell. Now this is length which give me the detail how many images is which we are using for the training time. Get cell IDX IDX basically is, you can say, retrieving the file name from the directories, or you can say it act as an index value. How we get the image path name, OS path name, first give image directory and image file name IDX. Same for the master directory. Now we have to read that. Read all this thing. Okay, convert this BGR into RGB because image CB2 run image into BGR format. Now convert now read the image of the mask in a grayscale format. Okay, That's why we are using I'm ready grayscale, or either you can use 0 here. Okay. Now what is use of this? NP where mask is greater than 0, we have to change all the values where the mask is greater than 0 to 1 and remain all values to 0. This is the meaning of this line. Okay, now if suppose any transformation is there, we have to perform that augmented self.transform image, augmented image, and augmented mask. Okay, and let me show you that. Let me explain. Explain you. I am using torch. I am using Albumentations insist instead of the torch vision transform. Okay, for the data augmentation part. So according to that only, I have to make changes here. If I use torch vision to transformer, so that time I have to individually perform transform on image and mask. But this time I am using augmentation. So for using the augmentation, the process is different. Okay, so that's why if you use torch transformer, you have to make sure you have to make transform individually on image and mask. Okay, and then make a and transfer that, not transfer, return that according to that only. Augmentation is contained one variable which contains two things, not that augmented image and a mask, and we have to retrieve that using this way. Now pass the return the image and a mask, and the data type of the touch mask is long type. Let me run it. Now this is the data augmentation part. A.compose resize the image into 125 horizontal flip, vertical flip, short random grayscale. Normalization is there because it increases the speed. Okay, the converting image into the tensor format. This is the augmentation part, and you already know what is the meaning of augmentation, data augmentation, and why we use. One reason is of the data augmentation is avoiding the overfitting. Dataset number of images increases. Okay, these are the directories. Now we have to create the object, just pass the image directory, master directory, and transform. Now using data loader, just give the transfer directory, the fetch size we want 8, suffer is true, drop last. What is use of drop last here? Sometimes when we make a means when we make a batches, suppose there is suppose there is a 41 images and I had created batch size of 8, so multiply with 8, divide by 8, it give me 5 batch, not 5, ultimately it give me, when we use data loader, it will give me 6 batch, and last batch contain one image only. Okay, so at that time training, during training, it will throw me the error that only one image is there, it should be contain more than one image for the training purposes. Okay, so that's why I have used drop last, means I don't want the last batch where the images is not there, images is less than 8, or less than 8 is there, like, okay, or only one image is there. I don't want those batches, so that's why I'm using drop last here. Now for the loss part, we are using CrossEntropyLoss, and we are using optimizer, Adam optimizer, pattern and learning rate will be 0.001. Let me run it. Is see 1169 is a trend, means 1169 are the images, and 146, see this, 146 146 into 8, it will give me 1168, means last batch, if I will not use drop last, it means last batch contain only one image and it's give me error during training, so we have to avoid that. That's why I'm using drop last here. To check that particular mask is mapping a correct image or not, or not. So same way, two classes there, but we want only one class. We have to change only one index and one where the in marks only one is present. I want to change that only, or we can say only segment that portion. Retrieve random batch from the train loader means this train loader will give me select the random batch from the 0 to length of loader -1. It will select the random batch from the train loader. After retrieving this, we have to iterate over it. It's it's give me images and mask both thing. Okay, train loader if batch idx is equal to random batch index. Okay, it will means it will iterate. If suppose there is one, suppose not 146 batch is there, it will iterate to one batch, second batch, third batch, fourth batch, five batch. But here random batch index, we have selected random batch index, so it will iterate, or we can say process only that batch which is matched with this random batch index. Okay, and now we have to plot images. 2 into 4 means 8 images we are plotting. Access the table, I will already explain you. Now images I permutate. Why we have used permutate here? Because when we use two tensor, it's change the dimension of the image from HWC from CHW. But I am sure that when we use I am sure here plotation during plotation, this I am sure function required HWC format. So to retrieve that, we use permutate 120 here. Okay, mask.numpy. Okay, mask greater than 0 to show you that how many values are present on greater than 1. Okay, or you can say there's no need of that. Just use now this thing. Till here I already explained you what we are doing. Okay, now plot the answer images and plot images. Let me run it now. See the plotation. You can see that data augmentation is applied, and you can see the highly contrasted images. Why? Because in we are using random brightness, contrast, or even when you normalize the pixels value, it get contrasted. Okay, now this is a training part. We do not have a validation data set, so we will not use validation loss for that. So let me explain you. This is west loss, which is a float infinity. We are giving that large number to west loss. Okay, now the model which we have saved with the path will be best model or PHP. We are using epoch 50, but this time I'm just using 2 here because I already downloaded the weights which is trained on 50 epoch. During testing time, I will load that weight and show you the result. I trade over the epochs model.train. Basically, now we are training the model, and you can say it's mean that weights has to be update or train. Epoch loss, initially the epoch loss will be 0. Images and mask should be on a same device. Optimizer is 0. I already not already in all my videos I explain you that meaning of optimizer or 0 means changing the gradient value to 0 before updating the weights values at each batch iteration, not epoch iteration, batch iteration. Because if suppose I will not do that, uh, uh, previous gradient value of batch will get accumulated in a current batch gradient value. Okay, and this time if it's get accumulated, it affects the updation of the weights, and we do not want that. So that's why we use optimizer or grid at batch iteration. Now just pass the images, and to retrieve the output use this thing. Okay, now calculate the loss. Just pass the outdated mask. Loss dot backward means here the calculation of the weights is performed, and here optimizer dot steps basically updation of the weights performed. Now epoch dot loss item, it will you can say loss of each batch is adding in epoch.loss. Now we have to calculate the average epoch loss just by entering the average loss per epoch and print that. If suppose best lost value, or we can say average epoch loss value, is less than the previous best lost, we will change the best loss value and save that model. This way the training has performed. Let me run it. Now this thing is a plotation after, or you can say testing time is here. Now this time I'm using a term, not using the Albumtation. You do not so don't get confused that why it's using Albumtation and why I do not use a Torchwind transform. So don't get confused. It's up to you. You have to use anything. You can use anything. Albumtation, transformer. It's up to you. Okay. So don't get confused. FCN-ResNet50. Torch.io bad model, already explained you. Now load the model. Classifier, we do not want any auxiliary classifier, just pay, already explain you everything here. Model to device, not here. Load the model. One more thing I want to explain you. Here I am loading the model in display model.state directory save path. Same way you have to load the model. Okay, load state load model at Matplotlib.device. Okay, this way you load the model. Okay, means there is a two or more ways to save the model, and each saving method has a different method to load that. So make sure that which method you are using for saving the model has to be used for at loading time only. Now image directory, plotation, I explain you, class, color class, transformer. Now here I'm using the composing means torch vision dot transform, resizing the images. I already tell you that during training time we have resized the images to 224 to 224. At passing the image or during the testing time we have to resize it to 224. Otherwise testing time it shows the error. And see one more thing, after converting the means before using the normalization you have to convert the image into tensor format, otherwise it will throw the error. Okay, now image random choice from the image path, just pass the image directory, convert the image into RGB format, ensure RGB format is there. Now transform means till here pre-processing of image is performed, means image format is will be CHW. Now unsqueeze 0, what's its do? Unsqueeze 0 will add one dimension, means VCHW format will formed. Now two devices, only know that model and image has to be on the same device. Now just pass the images and retrieve the output 0. Here output basically retrieve the images and 0 will give me the first image output predictions. Okay, till see here it's predicting the mask image, not any text format, it's predicting the mask image. Now torch.argument output dimension 0 cpu.numpy basically give me the predicted mask. Okay, predict mask will give me this thing. Okay, now convert the pill to numpy array. Okay, we are reading the image in the pill format. Okay, but here cp2 resize and this all calculation needed, that overlay mask and mask and image, all these three things has to be in a numpy format. That's why I'm converting the image into a numpy format after now this time retrieving the shape and width and size. Now we have to change the predictive mask resize into a 2024 format. In the same format the image size is there. Okay, interpolation enter nearest means if suppose may suppose not fill the value with the nearest pixels value. It says that pretty mass, original width, okay, original width and height. See, in uh, in the image directory or a text directory, it might the chances that the size of the image is not in a 2 to 2 format into 2 to format. It might be chances. So that's why we have to first retrieve the image size, and according to that only we have to change the predictive mask size. After that, just create the overlay, pass the images, and everything has to be performed. One more thing here, we are using masks, so use mask here only. Now this blended image. Now we have piloting the images, original image with the object is not subscribable. Let me think. Let me show you. Nee, first one more thing. Let me first pause this video and upload the weights which is trained on a 50 epoch. Let me first upload that. So this is a model Blood Cell .pth which is trained on 50 epoch. Let me change the path of the model. Okay, let me now run it. Cannot unpack non-literal it. Oh, image size. NP array image. So we get this too many values to unpack. So let me. Okay, it's give me height and width and channel also. And one more thing, it's doesn't image dot size give me width and height, but image dot shape give me height and width. Okay. And here is height. Now let me run it. See the result of segmentation on unseen dataset. Okay, it's working very good. It's working fine. Okay, it's segmenting the blood cell correctly and only changing that pixels value where the blood cell is there. Okay, now video is over. Please like, share, and subscribe. I will explain you everything like this only for easy explanation to provide easy explanation to you line by line. This type only like this. I explain you how the calculation has performed like is performed in here and why I have used this manually changeable do not use function. This type explanation if you want, please like, share, and subscribe. Thank you.